My name is David White. I'm a research analyst with the ARC group. I cover business intelligence, operational intelligence, analytics, those kind of areas for ARC. I do want to go through a little bit of introduction first, but before we do that, you might want to write down those URLs right there, bit.ly/IIoT blog and bit.ly/IIoT news. So ARC has put a couple of resources online recently. One is obviously a blog. The other is to sign up for a newsletter. But if you write those down, then we can stay in constant contact as the industrial Internet of Things evolves over time. So bit.ly/IIoT blog, bit.ly/IIoT news. So I did a survey back in June of last year. We looked at how organizations were using business intelligence and analytics and so on. One of the areas we asked about in that survey was people's understanding of big data. How is industry using big data? So one of the most telling data points that came back is that 38% of survey respondents didn't know what big data was. Perhaps more interestingly, they didn't actually know why they should care about it as well. So would anybody here think that they're in that 38%? They don't understand what big data is or why they should care? Okay, that's good. You'll also be very pleased that, thank you, we got one. I'm honestly very pleased that none of my panel put their hands up for that as well, so that's also very encouraging. So, well, let's talk a bit about what is big data then. And so, in my opinion, very simply for the folks in this room, big data is the industrial Internet of Things. Okay, it's that simple. And let's talk about why that is. Well, talk about aircraft, okay, for example. So in roughly the time it takes me to say this sentence, the engines on all the Boeing 787s currently in flight will generate 8.3 million data points. So it's 5,000 data points from every engine every second. 8.3 million data points in 11 seconds. So if we think about what big data is, and I like to use Doug Laney, who was at Meta Group, now at Gartner. He defined big data in terms of 3 V's about 15 years ago. Velocity, volume, and variety. So 8.3 million data points in 11 seconds. Clearly, we have a lot of velocity right there. If you want to store all that data, clearly we have a lot of volume we're going to accumulate over time. And also you can see we're taking data from many different sources than we did in the past as well. So again, I go back to my previous slide. As far as this audience is concerned, big data is the data from the industrial Internet of Things. So let's talk about why the original or the old approaches to analytics and business intelligence won't work in this new era. So over on the left here, this is kind of how BI's worked in the past. We dripped our transactions into our systems of record, the ERPs, the manufacturing systems, financials, and so on. We collect all those transactions up, and then at some point, we batch those up and we file them over to a data warehouse. Maybe we do that weekly, daily, maybe it's monthly, sometimes it's only every 3 months. And we lay our reporting and our dashboards and our analytics over the top of that. Well, that was fine then. When we speed it up and we have much more data coming in much faster from many different sources, partner data, public data, all kinds of information coming in, this situation doesn't work anymore. The whole notion of the data warehouse is going to break. You can use it for systems you had in the past, but it won't work for going ahead in the future. And the reason is very simply, there's just too much latency there. For us to get to events, to insight, via batching up all those transactions into an OLTP system, firing them across to a data warehouse, it just takes too long, that it's not going to work for the industrial Internet of Things. So the reason is, as we said, the latency. Okay, some of the information going into transactional systems is handwritten, has to be transposed still to get there. And as we said, sometimes that data coming across from the OLTP systems into the data warehouse takes weeks or months to do that. We can measure those latencies using a calendar, not a watch, often. So a couple of things we can do that, but to address that, but really we're talking about how do we take the latency out of that. So going back to where we were before, we have all these transactions coming in on the right-hand side. One of the things we can do is to merge the transactional systems with the data warehouse so they live in a shared database. Okay, so we're avoiding that batch transaction from the system of record to the data warehouse, taking that latency out of the system right there. The other thing we can do is to move our analytics and put it into the data stream as we collect it. So we're doing the analytics, or at least some part of the analytics, further to the source of the data. So things like real-time insight and visualization, stream processing, or complex event processing, which we'll hear about, which will give us insight into that data much, much earlier, and also put in predictive analytics on the edge as well. So those are just some of the approaches you can use, and we're going to hear about some of those over the next hour. As I said, we have 3 presentations for you. Eddie's going to talk about a smart metering system from Orlando Utilities Commission. Adam is going to talk about using complex event processing in discrete manufacturing. And then Scott's going to talk about the solution they have at Duke Energy as well. So they're going to last about 20 minutes each. Following that, we have Will Sobel and David Petrucci, who's going to join us for a panel discussion too.